Yeah. 1, 2, 3, 4, 5. Hi, I'm Cameron. A few friends and I have gotten together for board game night. One of our favorites is Probability Pad, which is more than just a game or subject in math class. Come on, let's head down that path and get another problem solved. But hold on while I win.
Ooh, not happening.
In the real world, probability is used to answer all kinds of questions, like what are the chances it will rain today? What are the chances you will win the raffle for a new bike? What is the likelihood that a baby will be a girl? Probability, like the game Probability Pad, has rules to keep in mind. Probability deals with future events. Probability can be expressed as a percent from 0 to 100% or as a rational number from 0 to 1. The probability of a certain event is 1 or 100%. The probability of an impossible event is 0 or 0%. The sum of the probabilities of all possible outcomes is 1 or 100%. The game is easy. Here's the start. The goal is to be the first to move your piece along the winding path to the finish. How far you move is determined by the spinner. Who wins is just a matter of chance. Shay has been doing well. If she spins a 5, she will win. What is the probability of her spinning a 5? First, look at the spinner. There are 10 possible outcomes. There are 4 1s, 2 2s, 2 3s, 1 4, and 1 5. Together, they represent all the possible outcomes, which is called the sample space. It looks like Shay is more likely to spin a 1 than any other number. Similarly, she is more likely to spin 2 or 3 than 4 or 5. Let's spin a few times and keep track of what we get. By collecting data, we can find the experimental probability. It's impossible to determine probability after just one spin. I got a 2 on my first spin. I will record this in a graph. Now, here are 10 spins. This is still not enough spins to accurately determine probability. A larger number of spins will give us more accurate results. Here's the graph for 100 spins. Let's record our results for 100 spins in a table. If you consider all 4 ways to spin a 1, out of 100 spins, we got a 1 36 times. Here are the other results of our experiment. The number of times we spun 2, 3, 4, and 5. The experimental probability of spinning a 1 is 3600. The numerator represents the number of times the result was 1. The denominator represents the total number of spins. The result was 1, 36% of the time. Here are the other probabilities. The results are consistent with our prediction. We are most likely to spin a 1, and 2s or 3s are more likely than 4s or 5s. We just determined the probability of spinning each number with an experiment. We could also determine the probability by analyzing the actual spinner. Take a look. The spinner is divided into 10 equal sections. 4 sections of the spinner show 1. In theory, we should expect to spin a 1 4 times in 10 spins. That's 4/10 or 40% of the time. This is the theoretical probability of spinning a 1. Here is the theoretical probability of spinning a 2, 3, 4, and 5. Notice the experimental and theoretical probabilities are close, but not exactly the same. We've looked at 100 spins, but watch how things change after 1,000 spins. The experimental and theoretical probabilities are even closer. Look at 10,000 spins. Woo! That'd be a long game. The more spins or trials there are, the closer the experimental probability should be to the theoretical probability. Are you starting to understand how probability works? Take another look at the board. Allie is 6 places away from the finish. What is the probability of her spinning a 6 and winning on this round? There isn't a 6. It is an impossible event. The probability of spinning 6 is 0 or 0%. Tina is 1 place from the finish. What is the probability that Tina will finish the game on the next turn if she needs at least a 1? Any number on the spinner will give her the 1 space she needs. This is a certain event. The probability of spinning 1 or greater is 1 or 100%. Lexi isn't doing very well. She has spun a 2 the last 5 times. What is the probability she will spin a 2 on her next turn? It's not a trick. Each spin is independent from the others. There is still a 20% chance that she will spin a 2 on her next turn. Allie hasn't spun a 2 the entire game. The probability that she will spin a 2 is also 2/10 or 20%. Oh no! If Kyle spins a 2, he will have to go back 10 spaces. What is the probability of him not spinning a 2? Well, since we know the probability of spinning a 2 is 20%, the probability of not spinning a 2 is 80%. Whoops! Sorry, Kyle. We've used probability to understand a simple game. But when we understand probability and apply these ideas to real life situations, everyone's a winner. Problem solved. It's my turn again. 1, 2, I win.